Hello and welcome. We're going to, in this video, examine how to use our calculator to deal with recursive sequences. There are several methods for this. Some methods are very valuable in relation to one particular question, and some methods are valuable in relation to a different particular question when dealing with recursive sequences. And hopefully this video will demonstrate that. Okay, so we have an arithmetic sequence here that we're going to deal with. Okay, it says u sub 1 equals 15. That is the initial value. And then it says that u sub n is equal to u sub n minus 1 plus 3. Some things about the reading here is you need to realize that when we say u sub n, it means any element of the sequence beyond the initial. And when we say u sub n minus 1, it just means the previous element to the one in question. So you should have those parts nailed down when you come to this video, because once we get to the calculator, you should have some understanding of how they really work. Okay, so let's take a look at this question, and we'll look at this from 3 different methods, okay? And then we'll maybe get a little compare-contrast real quickly for which method is good for which question that's being presented here. Okay, so there's 2 questions here. It says, what is the 15th number in the sequence generated by the recursive rule above? And then it follows up and says the 135th, meaning, well, what's the 135th one? Okay, if you notice in these 2 questions, to say the 15th, well, that's not very far into the sequence, okay? But the 135th is. So maybe that's where it's going to dictate which calculator method you use, okay? So I'm going to show you 3 different methods for this, and you need your graphing calculator. The first of which is just the very most straightforward method. It's to be able to enter the initial value on your calculator and hit enter. Okay? So from there now we examine in the recursive rule that what we want to happen recursively is to add 3 to the previous value to generate the next value. Okay? So to do that, we are going to just simply add 3 by hitting plus 3 on our calculator. And now you just have to realize which element of the sequence you're on. Well, 15 was first, so then you just have to carefully count when you hit enter. Second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th. Okay? So from there, you could sit there and say that U15 equals 57 by way of this method 1 we're doing. I'd like to think you already see that doing U to the 135th is possible by using this method, but very inconvenient, because you're going to be sitting there hitting that enter button for a long time. I hope you also see that hitting that enter button, going up to 135, you could just lose count, which is also inconvenient. So this brings us to method 2, okay? So method 2 is a little more complex, but it has an element of it that prevents us from losing count, okay? So it's going to involve making somewhat of a table in our, a pseudo table, I'm going to call it, because you don't actually use the table feature, okay? So to do this, we're going to incorporate the index and the value of the sequence. The index just means the first, the second, the third, or the 24th, or the 38th, or the 157th, okay? That's the index. So we're going to build a table for that, and you should be clicking along at home if you're watching this in the comforts of your own home, okay? And give this a shot, because this one's more complex. So we're going to go second left parenthesis, which is going to give us the squiggle bracket. And we're going to type in 1 for the index, of noting that it is the first element of the series. And then we're going to type the comma. Now next, we're going to type the initial value, which is 15, and then type second right parenthesis. What I've said here in this table is that the first element is 15. I'm going to continue to generate the table that's going to include the index, which is the number on the left, good vocabulary term, and the element of the sequence, which is the number on the right. Okay. Now, to do this, you have to understand something. You have to understand now that every time you do something on your calculator, we refer to the thing that came off last on your calculator as the answer. Your calculator recognizes that by saying ANS. So in this table, though, there's two answers. There's the one on the left and the one on the right. So your calculator notes them by answer 1 and answer 2. If the table had 5 elements in it, it would be answer 1, answer 2, answer 3, answer 4, answer 5, in that order from left to right. So to generate this sequence further, we need to go second, left parenthesis, and what I want to do is take that first answer, so I'm going to do second answer, left parenthesis 1, right parenthesis. And for me to just count my way through the sequence using the index, I'm just going to do +1. Okay? Because what will happen is that'll just continue to generate a sequence where I'm continually recursively adding 1. But that's not actually the sequence element. The sequence element is on the right side. So I'm going to take second answer 2, which in the previous line represents the 15. And I'm going to continue to generate the sequence by doing what's implied in the sequence, which is to add 3 to the previous value. So then I get second right parenthesis, which gives me the squiggle bracket. Now when I hit enter, it generates a table that makes sense. The number on the left is increased by 1. The number on the right has increased by 3. Again, increasing the one on the left by 1 makes sense because we're just counting through the sequence. Increasing the 1 by 3 on the right, which is the actual sequence element, makes sense because the recursion says to add 3. Now the good thing about this is I can just keep hitting the enter button, and I don't have to count because the counting's being done on the screen. Okay? So it says again that U15 is equal to 57. Okay? Well, it's easier to get to U135 this way because you can feel free to lose count when you're doing it, but the only disadvantage is that it takes time. But I will, in fact, pause the video for a second and show you that I can go there. So just take a moment and pause. And as I've turned the recorder back on and between the pause just kept hitting enter, you can see here that I've gotten down to the 135th element of the sequence, obviously, because it's marked, and that is 417. Okay? So, another good way to do it, more of an advantage in that you won't lose track, but you don't get an advantage if you're trying to find something very deep in the sequence. Let's just say while I paused that, I had to hit that enter button an awful lot. So, now, let's look at the third way of doing this. And in this way, you're going to see, wow, that's really the best way for generating a sequence value when given a recursive rule if they want something very deep into the sequence. And we're going to have to change our mode here by hitting mode. And if you see here on the 4th line, we're in function mode, but let's go to sequence mode. Okay? So we go to sequence mode and hit enter. Now when we hit the y equals button, we get a very different look than we've seen before when we use the y equals button. It's usually a graphing window, but we've taken it out of function mode and into sequence mode. Okay? So it says here that you have un, and then under that is un min. Well, I hope you realize that un min is the initial value. It's the first one. It's the smallest number of the sequence. The trick here is that these lines are a little backwards compared to the lines here that you usually see in writing. You usually see that the min value is up here and the rule is second. On your graphing calculator, that's a little bit reversed. So let's take a look here just for the sake of our mental process of starting with the minimum value. I'll down arrow and start with 15. And then I'm going to go up to U sub n to describe the actual rule. Well, you're going to have to find some U's on your calculator and some N's, and I'll point those out now. So the U is the shift button on 7 using second shift. So if you do second 7, you see that we get the U. Now I need left parentheses to do the subscript, The subscript in this case is n minus 1. The n is gotten by where the x is, which is 1 down and 1 right from the second button. Changing your calculator into this mode allows that button to be n. When it's in function mode, it is x. Minus 1, again, that tells us the idea of the previous value in the sequence. And then what we're going to do is go plus 3. Okay? Excuse me, not plus 33. Okay, so from there I can hit second quit. And instead of making any table whatsoever, I can do something very easily. I could just tell it which value I want by saying second u left parenthesis 15. And I'm just doing that to verify that that is, in fact, 57. And again, I didn't have to do any repetitive enter there. The calculator's really kind of giving you the answer. It's the most powerful, but I don't know if it reinforces the concept so much. And then second u left parenthesis for 135, right parenthesis, will in fact give you that value. So just to really try to exaggerate the point, excuse me, this is really a very effective tool for, God forbid, somebody said, what is the 7,892nd value in the series? Well, I hope you imagine you'd be hitting the enter button a lot, but in this way, unless the calculator futzes out because I've kind of gone with such a big number, but if you notice here, it's thinking because the number is way down in the sequence, and we should be getting it returned any moment, or some type of error message, because I've never tried to go this far. But it's interesting. It's even for a computer, it's letting you know, wow, that element is way down there. And to do this recursive computation is taking the computer a little bit of time. And just so we know, I actually hit the pause button there because the calculator was thinking, but it did actually return the 7,892nd element of the sequence, which is 23,688. Again, it's just gotten by recursively adding 3 to the previous value. It's interesting the calculator took quite an amount of time to do it because the calculator is supposed to be a pretty fast thing. Well, imagine if you weren't using the calculator in this way and you were hitting the enter button that many times. Ironically, you'd probably have to hit the enter button 7,891 times after you've entered the initial value. So these are the 3 different ways by which we can use our graphing calculator to deal with sequences. And my point was, it really depends on what the question is in terms of the style you would use. If they really ask you for something maybe that's very early in the sequence, like what's the 5th or 6th, and the recursion involved is not that complex, you might even get it fast just by writing it out. Okay? So deep into the sequence, the calculator helps. I like the second method for things that aren't too deep in the sequence because it accounts for the counting of the index, so you always know where you are. So again, picking the correct method is based on picking the type of recognizing the difficulty level of the problem or what specifically is being asked. I also want to make the point here that this works for any type of sequence, whether it's arithmetic or geometric. There's even probably other types of sequences it works for as well. If this were geometric, you just would not see repetitive addition and a constant difference. You would see something more of a multiplication. That would look like the rule saying maybe use of n was equal to 4.2 times use of n minus 1. And again, some initial value, maybe something like that. So the one I just wrote on the board is geometric. Now, the only thing I could say is you need to be careful when a sequence is giving to you starting at u sub 0 instead of u sub 1. It can throw off your count. I believe that in the middle model I gave you, you could actually start at 0 instead of 1, and that might be a good time to use the second model or the middle model that we did, because if you're starting at 0 and you're counting your clicks, your number of clicks are not equal to the number in the series represented by the index. So I hope you enjoyed this. Feel free to watch again and practice as often as you can. Put the can.